With the uniform motion experiment here, we've gone from a table of values to a scatter plot and then adding a line of best fit. And OpenOffice included the equation for the line of best fit. That was the 39.82, the equation. We're now going to go from our equation to our table of values. So I'm going to show you how to do that using an equation of a line. Let's open up a new document. We're going to open up a new spreadsheet. The equation we're going to use is y equals 2x plus 2. So we'll write down that equation just to let us know what we're dealing with. Now we're going to have x and y values. And we're going to run this from an x value of -2 to -1 to 0 all the way up to +2. But one neat trick that you can do with most spreadsheets is called the fill tool. If you highlight a pattern of numbers like -2, -1, and 0, highlight them, and then click on the black box, you can continue that same pattern down. So we'll continue the same pattern down to 4. Now we have our values for our independent variables set up. The next thing to do is create an equation so that it will determine the value of the dependent variable. So our equation is 2 times x plus 2. So to find our value of y, we need to take -2, multiply it by 2, and then add 2. There's a way of doing this within the spreadsheet. Whenever you make an equation, you have to put an equal sign. That's your first start. So we'll hit equals. And then we're going to type out the equation exactly as we had seen it. But instead of 2x, we don't want x. We want x to always be the number that's in that x cell. So instead of having x, I'm going to insert the value of that cell. So now I have equals 2 A4 plus 2. A4 is simply the letter and number that represent the spot of the cell. Now unfortunately we're not finished yet. We can't just sandwich numbers together, we have to let them know that we're multiplying, because the computer can't tell the difference. It would just read that as 2A4 plus 2. So we use an asterisk to indicate multiplication. We'll check this again. Our equation was 2x plus 2. Our equation that we have in our box is equals 2 times the value of x plus 2. So this should be right. You'll see that it instantly does the calculation. But in the input line up top, we see that the original equation is still there. Now we can type that out over and over again, but that would be more time consuming than bothering to do the calculations by hand. Fortunately, we have this fill bar. Grab the black box and drag the red line so it matches up with your last cell. When you let go, all of the values for your table of values are going to appear. So we now have all of our values for our table of values. We can now create from these a scatter plot and a line of best fit, just to double check our work. So I'll create a scatter plot. Recall we had to highlight everything, click Insert, and Chart, then XY Scatter, Chart Elements. Our title is going to be our equation. Our x-axis is x, our y-axis is y. We don't need a legend. And we'll click Finish. And now we have our chart that we've created from our table of values. We can again double check our work by clicking on the chart and inserting a trend line. We would expect our trend line to be the exact same equation as our equation that we had above. So when I hit OK on this linear trend line, we should expect the equation to be f at x equals 2x plus 2. And it is. So we've made no mistakes in our equation, and we've made no mistakes in our table of values. This is the real power of spreadsheet computing, using formulas to do repeated calculations. Whenever you have a large number of independent values that you have to do a calculation for, you should consider using a spreadsheet, rather than taking the time to calculate everything by hand. It can save you a lot of work.